Hello students, I welcome all of you to the science class. Subject Chemistry, Unit 11, Air. Today the topics to be discussed about oxygen, occurrence of oxygen, physical and chemical properties of oxygen and its uses. Next we will see about nitrogen, occurrence of nitrogen and physical and chemical properties of nitrogen and its uses. And at last we are going to see about nitrogen fixation. First, we will move on to the topic about oxygen. Before that, I want to give some introduction about air. What is air? Yes, you know that air is a mixture of gases that surrounds our planet Earth. It is essential for the survival of all the living things. You know, air contains 78% of nitrogen and 20.95% of oxygen and 0.93% of argon and 0.04% of carbon dioxide and small amount of other gases. We breathe as a human, we breathe in oxygen and breathe out in carbon dioxide, right? Plants in turn use carbon dioxide for photosynthesis and release oxygen into the atmosphere. Since men have been cutting down trees for their needs, the amount of carbon dioxide in the atmosphere is increasing. So this is responsible for the rising of atmospheric temperature. Industries and vehicles release gases like carbon monoxide and sulfur dioxide into the atmosphere. This has in effects of like global warming and acid rain which affect us in many ways. In total, the quality of air is gone in the modern days. Now let's we move on to the oxygen. All living things in the world need oxygen. We cannot imagine the world without oxygen. Swedish chemist Carl Wilhelm Scheele was first discovered in 1772. He called the gas as fire air or vital life because it was found to support the process of burning. It was independently discovered by the British scientist Joseph Priestley in 1774. Lavoisier named oxygen. The name oxygen comes from the Greek word oxygenes, which means acid producer. It is called so because early chemists thought that oxygen is necessary for all acids. Now we will see the occurrence of oxygen. Oxygen is the most abundant element on the earth by mass and the third most abundant element after hydrogen and helium in the universe. It occurs in both free state and combined state. It present in free state as dioxygen molecule in the atmosphere. Most of this has been produced by the process of photosynthesis in which the chlorophyll present in the leaves of plants uses solar energy to produce glucose. In combined state, it is present in the Earth's crust as silicates and metal oxides. It is also found in the water on the surface of the Earth. Trioxygen molecule that is known as ozone is present in the upper layers of the atmosphere. See the percentage of elements in Earth crust. 28% is silicon, 47% of oxygen, 3.5 percentage of calcium, 4.5 percentage of iron, 8 percentage of aluminium, and 9 percentage others, which are present in the upper layers of the atmosphere. Now we will see the physical properties of oxygen. Oxygen is colorless, odorless, and tasteless gas. It does not no color, no odor, and no taste. Oxygen is a poor conductor of heat and electricity. It dissolves readily in cold water. It is denser in air. It can be made into liquid, that is liquefied at high pressure and low temperature. It supports combustion, that is combustion means a burning. Now let's see the chemical properties of oxygen. The first property is combustibility, that is burning. Oxygen is a non-combustible gas, is a non-burning gas as it does not burn on its own. It supports the combustion of other substances. Do you know if oxygen has the capacity to burn itself means striking a matchstick will be enough to burn all the oxygen in our planet's atmosphere. Reaction with metals. Oxygen react with metals like sodium, potassium, magnesium, aluminium, iron, etc. to form their corresponding metal oxide, which are generally basic in nature. Metal plus oxygen gives metal oxide. Metal plus oxygen gives metal oxide. For example, take a sodium metal and oxygen, it gives sodium oxide. See, 4Na plus O2 gives 2Na2O. Na element is sodium, O2 is oxygen, it gives sodium oxide, that is 2Na2O. Reaction with nonmetals. Oxygen reacts with various nonmetals like hydrogen, nitrogen, carbon, sulfur, phosphorus, etc. to give corresponding non-metallic oxide, which are generally acidic in nature. See, non-metal plus oxygen gives non-metallic oxide. For example, take carbon plus oxygen, it gives carbon dioxide. Carbon plus oxygen gives carbon dioxide. If the metals react with reaction, it gives carbon dioxide. What reaction with hydrocarbons? Hydrocarbon is a compound containing carbon plus hydrogen. It reacts with oxygen to form carbon dioxide and water vapor. For example, wood, petrol, diesel, LPG, etc. When they burn in oxygen, they produce a height and light energy. Hence, they serve as a fuel. See, hydrocarbon plus oxygen gives carbon dioxide, water vapor, heat energy, and light. Hydrocarbon and oxygen gives carbon dioxide, water vapor, heat energy, and light. Next is rusting. The process of conversion of iron into its hydrated form of oxide in the presence of air and moisture, that is, moisture means humid atmosphere, is called rusting. Rust is hydrated ferric oxide. 4Fe plus 3O2 gives 2Fe2O3. Fe means iron, O2 is oxygen. Fe2O3 plus XH2O gives Fe2O3XH2O. Fe2O3XH2O is rust. Here X is equal to number of water molecule which is variable. Next, see what are the uses of oxygen. Oxygen is used as a oxyacetylene light. Oxyacetylene light is used for cutting and welding metals. It is used to remove carbon impurities from steel. Plants and animals use oxygen from air for respiration. It is used to oxidize rocket fuel. It is also used for artificial respiration by scuba divers, mountaineers, astronauts, patients, etc. Oxygen mixed with powdered charcoal and it is used as explosives. Oxygen is used in the synthesis of methanol and ammonia. We are going to see the another element, that is nitrogen. Nitrogen is one of the most important elements. Animals and plants need nitrogen for their growth. All living organisms, including us, contain nitrogen. It is an essential element present in proteins and nucleic acids, which are the building blocks of all living things. It was first isolated from the air by Swedish chemist Carl Wilhelm Scheele in 1772. The name nitrogen is derived from the Greek words nitron and gene, meaning I produce nitre. Nitre is potassium nitrate, compound of nitrogen. Next, we will see the occurrence of nitrogen. Nitrogen is the fourth most abundant element in the human body by mass. It accounts for about 3% of the mass of the human body. It is thought to be the seventh most abundant element in the universe by mass. Titan, the large moon of Saturn, has an atmosphere made up of 98% of nitrogen. As oxygen, nitrogen occurs both in free state and combined state. Nitrogen exists in free state in the atmospheric air as dinitrogen. It is present in volcanic gases and gases evolved by burning of coal. Nitrogen is present in combined state in the form of minerals like nitre, that is KNO3, and chile saltpeter, NaNO3. It is present in the organic matters such as protein, enzyme, and nucleic acid, etc. Now we will see the physical properties of nitrogen. You know that nitrogen is colorless, tasteless, and odorless gas. It is slightly lighter than air. It is slightly soluble in water. Nitrogen becomes a liquid at low temperature and looks like water. When it freezes, it becomes a white solid. It is neutral to litmus like oxygen. Now we will see the chemical properties of nitrogen. First property is chemical reactivity. Nitrogen is inactive at ordinary conditions. It combines with many elements at high temperature and pressure or in the presence of catalyst. Second property is combustibility. Nitrogen is neither combustible or nor a supporter of combustion. Already you know combustion means burning. So nitrogen in the air moderates the rate of combustion. Reaction with metals. Nitrogen reacts with metals like lithium, calcium, magnesium, etc. at high temperature to form their corresponding metal nitrides. Metal with nitrogen gives metal nitride. For example, take calcium. If calcium with reacts with nitrogen, it gives calcium nitride. I repeat, calcium react with nitrogen, it gives calcium nitride. 3Ca plus N2 gives Ca3N2, calcium nitride. Reaction with nonmetals. Nitrogen reacts with nonmetals like hydrogen, oxygen, etc. at high temperature to form their corresponding nitrogen compound. When a nonmetal reacts with nitrogen, it gives nitrogen compound. For example, take hydrogen with nitrogen, it gives ammonia. See, 3H2 plus N2 gives 2NH3. Now we will see the uses of nitrogen. Liquid nitrogen is used as a refrigerant. It provides an inert atmosphere for conducting certain chemical reactions. It is used to prepare ammonia by Haber process, which is then converted into fertilizers and nitric acid. It is used for inflating tires of vehicles. It is used for filling the space above mercury in high temperature thermometer to reduce the evaporation of mercury. Many explosives such as TNT, that is trinitrotoluene, nitroglycerin and gunpowder contain nitrogen. It is used for the preservation of fresh foods, manufacturing of stainless steel, reducing fire hazards, and as a part of the gas in incandescent light bulbs. Do you know nowadays nitrogen is used as a substitute for compressed air in tires? Have you noticed it? Why do people prefer nitrogen instead of compressed air in tires? Search and tell me, students. Next, we will see about nitrogen fixation. Nitrogen gets circulated in the air, soil, and living things as the element itself or in the form of its compounds. Just as there is a circulation of carbon in nature, so also there is a circulation of nitrogen. It is essential for the proper growth of all plants. The plants cannot make use of the elemental nitrogen from the air as such. The plants require soluble compounds of nitrogen. Plants depend on other processes to supply them with nitrites. Any process that converts nitrogen in the air into a useful nitrogen compound, it's called nitrogen fixation. We said nitrogen fixation is a process that converts nitrogen in the air into a useful nitrogen compound is called nitrogen fixation. Fixation of nitrogen is carried out both naturally and by a man. Now we will see the mind map for nitrogen fixation. Nitrogen fixation has two types. One is natural fixation and other one is artificial fixation. In natural fixation, it has two types. What are they? Natural fixation from leguminous plants, and another one is lighting. Natural fixation from leguminous plants, and another one is lighting. In artificial fixation is also have two types, from ammonia and ammonium salts, and from nitric acid and nitric salts. Students, that's all about the session. Today you know about the occurrence and composition of oxygen and nitrogen. In next class you will know about the carbon dioxide in the atmosphere. Now you know the properties and uses of oxygen and nitrogen. I hope you know the composition, properties and uses of oxygen and nitrogen, and now you understand what is nitrogen fixation. Next one is assignment. Write the physical properties of nitrogen. Here I have attached the answer for the given question. Kindly note it down in your notebook and don't forget to submit it in the GCR. Thank you.